Some of you asked the third question. A particle starts from rest, u equals to 0. Acceleration at 2 meter per second square for 10 seconds. Okay. A particle starts from rest. It will accelerate. They given acceleration at 2 meter per second square for 10 seconds. For 10 seconds, starting from A to B. For 10 seconds, what is the acceleration of the body? 2 meter per second square. So during the 10 second, whatever distance covered, you can say S1. Right? Next. Okay, next. Then goes with constant speed for 30 seconds. After 10 seconds, the next 30 seconds. Next 30 seconds, it is going with constant speed. Here the speed is what? Constant. Right? Whatever during 30 seconds, whatever distance covered, let me call S2. Next what is happening here? And then decelerate at 4 meter per second square till it stops. From here, decelerates means its speed decreases. From here, it decelerates. Finally, it comes to rest. Then, during this deceleration, okay, how much distance it will cover? Let me call it as 3. The deceleration is given. What is this deceleration? Why should I take minus? Because it is decelerating. 4 meter per second square. Right? Whatever distance it will cover during here to here, probably they given and decelerate, and what is the distance traveled by it. Right? So during this here to here, whatever distance it will cover, that will be S3. Now go for find the S1. How will you find S1? You can use S1 is equals to ut plus half at square. U is 0, half. A is what? 2 here. T square here to here. What is time? 10 square. You will get S1. 2 gets cancels. It will be 100. S1 is there. Now by the time it reaches here, what is the final velocity? You find it. Because the same velocity is maintained for the next 30 seconds. What is V? I'll find the V using this V equals to U plus AT. What is U here? 0. Plus here to here, what is acceleration? 2. Here to here, what is time taken? 10. So it will be what? 20 meter per second. What is the velocity by the time it comes here? 20 meter per second. Now with the same 20 meter per second, it goes some distance S2 over the time 30. What is S2? Let us find S2 here. Because it is constantly moving, so no kinematic equation. Simple equation of V into T is equals to, what is V here? Same V, 20. Time. Here to here, what is the time here? 30. So it will be what? 600. So what is S2 here? 600 meter. Now here deceleration. Okay, by the time it comes here, same here to here, what is the velocity? Here also 20 meter per second. This will act like the initial velocity for the next. S3 we have to find. A we know. Can I use this equation here? B square minus U square is equals to 2AS. Here S, which distance here is? S3. What is the final velocity? 0 square. Initial is what? 20 square. 2. Here deceleration is given -4. Find out. S3 is, I will write here S3. S3. Therefore, now here what? -400. It will be 4 to the -8 into S3. Minus cancels. 8 1 8 50 the. So what is S3 here? 50 meters. Okay, here no kinematic equation, simple S equals to Vt. Here kinematic equation, starting velocity, final velocity, right, S3. And here starting velocity is 0, final is this, we have found it. Okay. You sum up all the things. What is total distance? S equals to S1 plus S2 plus S3. What is S1 100? S2 is 600. S3 is 50. Therefore, it will be 750. Right? Okay, for 10th. 10th is, okay, that's the integration concept. Probably there you may, okay, let me tell you. Acceleration of the particle starting from rest varies with they given here. Acceleration is not constant. They given acceleration as a function of time. What is the meaning of this? This is not uniform acceleration. Acceleration is changing. Sometimes 10 meter per second square, sometimes 20 meter per second square. Depending on time, the value of is changing. Right? Okay. If you write it in differential form, how do you write A? Change in velocity by time taken is equals to alpha t plus beta. Right? What we are asked to find, you can see, we are asked to find, okay, the velocity of the particle after t time. Right? Velocity of the particle after t time. Okay. Now, dv is equals to, take dt that side, alpha t into dt plus beta into dt. This dt is multiplied to both. Okay. Now, integrate both sides. Why we use integrate? This is a small change. This is a small change, infinitesimally small change in velocity. I want integrated final velocity. I want velocity of the body somewhere at the time t. This is a microscopic change. Integration means what? Summing up of smaller change over big time. Integrate both sides means we want one definite big value. Regarding integration, we'll nurture more and more in the later classes. So if you integrate it, integrate both sides. Integration of dv, there is a formula in mathematics. It will be v. Right? So integration of, here alpha is constant. You will take it out. Integration of t, and I told you integration of x with respect to dx will be x square by 2. It's a formula. For definite integral, later you learn it. So x1, x2, you can, if it is integrated over definite integral, you have to write it like that. Here we have to find velocity over the time 0 to t. So here dv has to be converted into time and all. Just integration of dv will be v. Here time is integrated over 0 to t, 0 to t. So it will be what? Alpha integration of t with respect to, this is t square by 2 over the limit 0 to t. Time is varying from where to where? 0 to t. Here beta, integration of dx. These things probably it's difficult to catch. This some depends on integration. So as of now, you catch it. This one. So later, as the time progresses, we will come to know more and more about integration. So as of now, what is integration of dx is x? For the definite integrals, you have to take limits. So here we are integrating dt integration will be what t over the limit 0 to t. So will be v equals to alpha t square. This can be written by 2 and it is what? Final limit 0 square by 2 plus beta final limit minus initial limit. It will be what? Alpha t square by 2. 0 by anything is 0. So it will be plus. Here it will be what? T. But it is integration wise. Just to remember formula and stick to what process is. It's in and out and in detail. You will come to know as the time goes on. Okay, this is how it can be done. Thank you.